Hi everyone, my name is Robin Abraham and this is my submission towards the Machine Learning Foundations for Product Managers as part of the AI Product Management specialization from Duke University's Pratt School of Engineering. This is the original dataset which was submitted, and the intent is to find an algorithm or an analysis that would help us try and predict the values of PE, which is the label in this data set. There are four features, as you can see: ATV, AP, and RH, based on which the value of PE is actually being predicted. There are about 9,600 observations in the entire data set. So one of the first steps that you're trying to do is to try and split the data set into the training set as well as the test, so that you have some observations using which you're actually going to be predicting the values of PE, having trained your model first. In this case, I'm actually going to be using something simple, which is going to be the regression analysis. It's a multiple regression, given that there are four values or four features that you have available, and the value of P is to be estimated. So the first thing I did was to split the data set, as I said, and the first one consists of the first 7,600 assets as part of observations as part of the training set, and the last 1,900 being kept as the test set. Running the multiple regression analysis, as you can see, trying to predict the value of PE. The characteristic that I'm most interested is in the R-square and the adjusted R-square, which are used to try and explain the variance within the predicted value of the label versus the observed value of the label. And in this case, you can see that it has done a fairly decent job. It's able to actually explain about 93% of the variance, and 93% is a fairly high number. So it's a fairly good first attempt of trying to build an algorithm or build a model that's going to try and predict your values of PE. Having run the model, then I have gone down and created the test set, and here you can see the predicted values of PE, use the coefficients and the intercept that were identified as part of the training set. So it's gone ahead and I've tried to use the intercept and the coefficient values to try and figure out a value of the predicted PE. Having done that, I've then run a correlation between the predicted values and the recorded observed values of PE, and you can see that there's a 96% correlation between these values, which is a very good measure. Having done that, I then split my data set into in a different way, wherein the training set consists of everything but the first 2,000 records, and then ran the regression analysis again. There's not a statistically significant difference between the first run in terms of the first run and the second run. The values are fairly close enough, which indicates that the data set is fairly well balanced in terms of the observations. The test runs as well indicate a decent correlation between the observed values as well as the predicted values. Having done that, I then ran a correlation between the features, between all the columns put together, and between the columns, between the features and um, the label. You can see that there is about a 94% negative correlation between the first feature and the label, and similarly a negative one for the second feature and the label, a positive correlation for the other two columns. With this in mind, I then ran a regression without the third label to try and see if that makes a difference in terms of the characteristic that I'm trying to use for observing my model performance. It actually drops. It's not a significant drop, but there's a drop in terms of the model characteristic which is R square, which I'm trying to use. And similarly, I then ran the second regression without using two features, both RH and AP, and the and the result was somewhat similar, that the model performance dropped when I started eliminating certain features and not using all the 4 features. So the best model was produced when I used all the 4 features to try and predict the value of the label, which was PE, and we should probably go ahead with that specific model in order to do the predictions. Thank you very much.